Hello everyone, welcome to my channel. I hope you all are well and having a very good day. I'm very excited that you have come here to learn something. So before begin, make sure you have subscribed my channel and pressed the bell button to get the latest updates about the topics. So let's dive into this topic then. So we will solve a problem of traveling salesman using exact algorithm. What is exact algorithm? Exact algorithm gives exact optimal solution, but it may be take much time. Its time complexity may be exponential, but we will try to solve it using dynamic programming. So what is the question? The question is here: design an algorithm to solve the traveling salesman problem. First of all, if you don't know what is traveling salesman problem, I'm giving you the definition. Traveling salesman problem is a problem where you are given some cities and you are given the cost from traveling from one city to another city. Okay, so you have to visit all the cities just once and you have to come in the starting point. That means you will create a cycle, visiting all the cities, just visiting once. This is the traveling salesman problem. I hope you understand this. Now let's dive into this problem. We have to where input is a distance matrix. Input means the cost. Okay, this is the costs between a set of cities, and the goal is to find minimum length tour. We have to find minimum length tour. Okay, this minimum length tour that visits each city exactly once before returning to the starting point. So given the following distance matrix, this is the distance matrix we are given. You can see at the right corner. Distance matrix, find the minimum length of the city tour. Minimum length of the city tour. Okay. This question is from BUET Term Final 2020-21, and this is for level 4 term 2. Okay, so this is our input matrix. And what does this mean? I will give an clear explanation about this. I'm marking something. This is CT1, CT2, CT3, CT4. This is CT1, CT2, CT3, and what? CT4. Traveling from CT1 to CT1 will cost 0. Traveling from CT1 to CT2 will cost 10, and the cost to travel to city 3 from city 1 is 15, and if we want to travel to city 4, then it will cost 20. So I hope you have understood this matrix. Now let's dive into the solution. We will use an algorithm to solve this problem. First of all, will solve smaller sub-problems. Then we will use the solutions of smaller problems to solve the bigger problem. Okay. So as we can assume that we can start from any city, right? Because this is a cycle. As this is a cycle, we can start from anywhere. So we are assuming that we are starting from city 1. You can also assume that you starting from city 2 or city 3 and so on, no problem. And let S be a non-empty subset of other cities. Okay, S be non-empty set of other cities rather than city 1, and these cities belongs to this set. This is the set actually, and this is very important, students. Let M S C I be the minimum length of a tour which starts in city 1. All tour will start in city 1. We are assuming that in the first point. So it starts in city 1, visit all cities in S, this is S, and ends in CI. This is the CI. That means we have to traverse all the cities in S, and we have to end our journey in CI. Okay, we end at CI. Okay. So this is very important. Now let's try to solve it. First of all, we will solve the most small problem, smallest problem. So the smallest problem is of cardinality 1. That means let's say we are starting our journey from C1 and we end our journey C2. This is a problem. We start our journey C1, we end our journey C3. This is another problem. We start our journey C1 and we end our journey C4. So let's try to solve it. For this, cardinality is equal to 1. We can try to go to C2, end our journey at C2. What does this mean? We have started our journey at C1 and we end at C2. And this is actually distance C1 to C2. And what is this? This is actually 10. You can look at here C1, C2, C3, C4, C1, C2, C3, C4. So this is 4. Then another example we can use C3. We are visiting C3 and we end our journey at C3 and we start our journey from C1. So this means we go from C1 to C3. And what is this? This is actually 15. And we can also end our journey at C4. Then this should be C1, C4, and this is 20. So 10, 15, 20. Then we will use these solutions to solve a bigger problem with cardinality 2. Okay, so let's write it at the left corner. I have write these solutions at the left corner that I solved in the previous slide. Then to solve this problem with cardinality 2, we we can write m cardinality 2. Okay, so we are starting our journey from C1. We can visit C2 and C3. Okay, and we can end our journey either at C2 or at C3. So we can end our journey at C2 or we can end our journey at C3. Then what will this cost? Okay, uh, we are ending our journey at C2. That means we have already visited C3. So we have already visited C3, ended at C3. Then we have visited C2. After C3, we have visited C2, C3 to C2. And what is this? C3, C3 is 15, and C3 to C2, C3 to C2 is 35. And this is 30, 40, and 50 students. Then in the second example, look at here. We we are visiting C2 and C3 and we are ending our journey at C3. That means we have already visited C2. We have to visit C2 first. Then we have to visit C3. And what is this? MC to C2 is 10. You can look at here is 10. C2 C3 is 35. This is 45. We are done with set C2 and C3, but we have more two sets. We can also do this with C2 and C4, and we can end at either at C2 or at C4. So if we end at C2, also we can end at C4. Okay. So what is the third example? We are ending our visit at C2. That means we have already visited C4. So this should be C4. We have to visit C4 first. Then from C4 we have to go to C2. And M C4 is 20 and MC4 to C2 is 25. So this is 45. Then C4, C2, C4, C4. We are ending our journey at C4. That means we have to visit C2 first. So let's visit C2 first. Then go to C4 from C2. And C2 is 10. And if we want to go C2 from C2 to C4 is 25. And this is what? This is 35. So we are left with only one set, and that is C3 and C4. So let's change the color first. M, C3, C4. We can end our journey at C3, or we can end our journey at C4. Okay, if we end our journey at C3, that means we have to visit C4 first. So let's visit C4 first, then move C4 to C3. C4 is 20 and C4 C3 is 30, and this is actually 50. And in the last example, we have to end our journey at C4. That means we have to visit C3 first. C3, and we have to travel from C3 to C4. And what is this? C3 is 15, C3 to C4 is 30, and this is 45. Okay, we have solved 6 examples with cardinality 2, and we will use these solutions in the next bigger problem. So I have written this here 50, 45, 45, 35, 50, 45 that I solved in the last slide. Now solve it for the cardinality 3. So what will be the set? Okay, M, C2, C3, C4. Okay, this is the set, and we can end our journey in C2 or in C3 or in C4. So if we end our journey C2, then what will happen? Look at here. This is very important. We are trying to end our journey at C3. So in the smaller problem, you have to remove the C2 first. Okay, you have to remove the C2 first. So if you remove the C2 first, then you will get C3, C4. Okay, this is the set. And again, you can you can end your journey either at C3 or at C4. That means if you end your journey C3, then after that you have to move C3 to C2. So understand it again. The set is with the set consists of C2, C3, and C4, and we are trying to end our journey at C2. That means first we have to solve this problem with C3 and C4. We have to solve this problem with C3 and C4. Then we will move to CT2. So solving C3 and C4 can be done in 2 ways. Solving C3 and C4, for solving C3 and C4, we can either end our journey at C3 or we can end our journey at C4. We can end our journey at C4. So before going to the C4, let's calculate it here. What is M343? M343 is 50, and distance from C3 to C2, this is C2. Let me make it clear. C3 to C2 is 35, and this is 85. But we can do this, we can solve C3, C4 subproblem in another way. that is M. We are trying to solve C3, C4. We can end our journey at C4. We solve the smaller subproblem of C3, C4. Then from there, we will travel to C2. From C4, we will travel to C2. And what is this? C344 is 45 and C4, C2 is 25. This is 70. So we can solve this problem in these two ways. And what is the minimum cost? We have to take the minimum one. So take minimum of this, and this is 70. So I hope you understand this. If not, no problem. I will show another two examples corresponding to this. Again, we can solve our problem C2, C3, C4 ending at C3, right? Ending at C3, we also can solve this problem. So we are ending our journey at C3. So remove it from this set. So we will have the smaller subproblem with C2 and C4, C2 and C4. We have the smaller subproblem, and this smaller subproblem can be solved in two ways. We end at C2, okay, or we end at C4 in two ways. C4. But in the bigger example, we have to end our journey at C3. That means from C2, we have to move to C3. C2 to C3. And from C4, we have to move to C3. And what is the cost of this? 242. 242 is 45. Write it here. And 23 is 35. From this is 35. So I'm writing 35, and this is actually 80. And what is this cost? C244. 244 is 35. And what is the cost from CT4 to CT3 is 30. And this is 65. So again, we have to calculate the minimum. So let's understand it again. What is the first line? We are trying to visit these three cities, City 2, City 3, City 4, but City 2 will be at the end. And we can visit this in two ways. From City 1, City 4, City 3, City 2. This way. Or City 1, City 3, City 4, and City 2. Okay? City 4 is the ending point, is the last point of solving this problem. Then we are traveling at City 2. In the first example, to solve City 3, City 4, we are using City 3 as our finishing point, and after that, we are going to City 2. So in the third example, look at here, we are trying to visit City 2, City 3, City 4, starting from City 1 actually. So, and we are trying to end our journey at City 3. We can do this in two ways. We can go City 1 to City 4, then City 2, then City 3. Or City 1, City 2, City 4, City 3. So to solve this, actually, we want to end our journey at City 3. Just remove it from this set. Then we got the smaller subproblem with City 2 and City 4. And this smaller subproblem, City 2 and City 4, can be solved in two ways. We can either end our journey at City 2, or we can end our journey at City 4. And this is already solved. We are using these solutions, these values from here, and just putting it here. So in the last one, let's dive into it. M, city 2, city 3, city 4, and we are ending our journey at city 4. And as we are ending our journey at city 4, remove it from here. We will have the smaller subproblem of city 2 and city 3. Then we have city 2 and city 3. And we can solve it in two ways. Either we can end our journey at city 2, then we have to move from city 2 to city 4, because in the bigger problem we have to end our journey at city 4. Okay, let's write it more clearly. Okay, so what is the value of this? 232 is 50, 2 to 4 is 25, so this is actually 75. And we can solve city2 and city3 in another way, that is city2 city3, and we end our journey at city3. Then we go to city 4 from city 3. Okay, this is 4. Let's write it clearly. Okay, so 233 is 45, and 324 is 30, and this is 75. We have to take the minimum from here. We also take the minimum from here. Let's write it here. This is 75. And what was the color? This was blue. And this was the 65. We obviously will try to solve it with minimum values, because this is the minimization problem. So what are the values of this? This is 70, 65, and 75. Let's write it here. 70, 65, and 75. We have found this. Okay. If we end at city 2, we will get 70. If we end at city 3, we will get 65. And lastly, if we end at city 4, we will get 75. I have write it here. Then last one. Then after that, we have to go to the city 1 again. So M, city 1, city 2, city 3, and city 4, and we have to go to the city 1. Okay, we have to end our journey at city 1 because we started our journey from city 1. Okay, then what is this? This is actually minimum of 4 terms. So we are ending our journey at city 1, so remove it from here. Then we will have this smaller subproblem, city 2, city 3, city 4. And this smaller subproblem can be solved in different ways. First of all, city 2, city 3, city 4. This can be solved uh, uh, assuming that we are ending our journey at city 2. So we can write it here. Then after city 2, then we have to move to the city 1 again. This is one case. Another case is city 2, city 3, city 4. We are ending our journey at city 3. Then from city 3, I'm going to city 1. This is another case. And lastly, city 2, city 3, and city 4. We are ending our journey at city 4. And then from city 4, we are going to city 1. This is another case. Okay. So what is the value of this? 2, 3, 4, 2, 3, 4, and ending at 2 is 70. This is 65. This is 75. 2 to 1 is 10. 3 to 1 is 15. And 4 to 1 is 20. This is 80. this is 80, and this is 95. Then what is the minimum of this? The minimum of this is 80. So there are two ways we can travel to city 3, then city 1, we will get 80, or we can travel city 2, then city 1, we will also get 80. Obviously, we have to visit city 3 and city 4 before that. So this is our optimal result of this traveling salesman problem. So I hope you have understood this problem and enjoyed this video very much. If so, then please give a thumbs up button, and share this video with your friends. And also try to subscribe my channel, and leave a comment below if you have any doubts, and if you have any questions about these topics. I will try to see and answer those quickly. So till then, keep smiling and keep learning and be active and productive. So thank you everyone for watching this video. Bye.